the idea of composition of functions falls under the idea of functional arithmetic. And the definition of the composition of functions is f of g of x is equal to the function f evaluated at g of x. Now the thing is, this guy is a little circle. It's not the letter O. It's not a dot. It's just a small circle, and it means f of g of x. See, if we're talking about the function f, what we normally do is we take an x value and we plug it in, then a whole bunch of stuff happens, and what pops out is another number that we call f of x. In the case of the composition of functions, what we're going to do is take that same x, and the first thing we're going to plug it into is g. And what we'll get out of there is g of x. Then we take that result, whether it's a number or an expression, and we're going to plug it into the next function, f. And what we'll get out of there is f of g of x, or the composition of the two functions. So it's really kind of a chain. We're going to take the value, plug it into one function, take that result, and plug it into the next function. So let's let f of x equal 2x plus 7 and g of x equal x squared. If I want to find f of g of 2, then we're finding f of g of 2. So we're going to take that 2 and plug it into the function g first. Right? G is x squared, so we're going to square 2. That'll give us 4. Now we take 4, that result, and plug it into f. 2 times x plus 7, but our x here is 4. 8 plus 7 is 15. Okay. Now if we want to find the same composition of functions, except this time in a more general idea, with x instead of an actual value, we're still going to find f of g of x. In this case, g of x is x squared. So we're going to take x squared and plug it into f. Oops. So 2x plus 7, that's f. And we're, instead of using x, we're going to use x squared, this value. So simplifying, that's just 2x squared plus 7. Let's do it again. Let's let f of x equal 4x to the negative 1, and g of x is 5x minus 2. So if we want to find f of g of x, that's f of g of x. G of x, we said, is 5x minus 2. So we're going to take that and plug it into f. So we're going to take that 5x minus 2 and plug it into f for x. Now we can simplify this a little bit more because we see we have this negative power, and what a negative power does is take the base and put it in the denominator. So now we have a simplified expression. Let's do it again, but switch the order around. So instead of finding f of g, we find g of f of x, which means g of f of x. Does order matter? Should we end up with the same thing? Well, let's find out. What I'm going to plug into g is the function f, 4x to the negative 1. And that's going to get plugged into g of x up here. So 5x minus 2. And we're going to plug in 4x minus to the negative 1, which leaves us with 20x to the negative 1 minus 2. And these two expressions are obviously not the same. We can simplify it a little bit more because of that negative power, which means the base goes in the denominator. Not 20x doesn't go in the denominator. 20 stays on top. It's only x that's being taken to the first power. So it's x that goes into the denominator. And then minus 2. And we see that order does matter when we're talking about the composition of functions. Another problem that you're not going to see in your book, but I want to talk about it anyway. What if I told you what the composition of functions was and asked you for the original functions? Well, when we look at the square root of x plus 5, we see that there's two things that are happening to x. There's the x plus 5 is happening, and then there's the square root that's happening. When we think about f of g of x, that's two functions that are happening. We're taking the first function and plugging it into the second function. So when we think about this, there's really an inside function and an outside function. The thing that happens to x first would be the inside function, this x plus 5. Well, when it comes to the composition of functions, the first thing that happens to x is g of x. So I'm going to take that x plus 5, and that goes for g of x. Then, after we did that, we would take the square root. So that's how we'd break up our composition of functions into two separate functions by thinking about the inside and the outside, the thing that happens first and the thing that happens second. So if we saw f of g of x is equal to x minus 8 cubed, we see there's two things happening. There's x minus 8 that's happening, and then there's a cube that's happening. The inside function, the first thing that happens is this x minus 8, so that's g of x. The second thing that happens is the cubing, so that's the second function, x cubed. Basically, the thing to remember goes back to these types of problems where if we want to find f of g of something, we're going to take that something, plug it into g first, and then take that result and plug it into f.